Yes. So let's get started. Okay, so last week, guys, we talked about solving a single-step equation either involving additions or subtractions, such as this. Quick review here. Well, I know it's not like major or anything like that, but it's just figure it's better off. This is called single step because notice that we are trying to get rid of this positive 5, right? And how do we get rid of that one? We minus it over. We don't want to isolate your x. We minus the 5 over, and we end up with just a 2. That is called for removing one whole term. Remember I talked about that before. The idea of removing one whole term involves adding something over or subtracting something over. And then we move on to something with this. For example, now this time I have negative 2 times x equal to 7, and I'm just removing what here? Okay, the negative 2, this is what I'm trying to get rid of, the negative 2. And negative 2 is actually the whole term or just a coefficient? Okay, so we talked about coefficient before. How do we get rid of the coefficient? Either divide or multiply by the reciprocal. So we have 2 ways to do it. Very good. And for those of you who love division, you can. You end up with this, 7 over negative 2. However, remember I told you that the multiplying by the reciprocal will work all the time. It's a guarantee way to get it done right. So if you do it using the reciprocal, if it helps you remember I did something like this, zoint and zoint like that, you know? And what is the reciprocal of negative 2? Okay, negative 1 over 2. Notice the sign doesn't change, okay? Reciprocal doesn't mean you change the sign. It simply means you flip the numerator and the denominator. So there you have it. This will get canceled. X here is negative 7 over 2, and you get the same answer as well. So it's just a quick review over 2 lessons we covered, okay? And then at the end of the day, last week, I also partly covered multi-step equation solving with you. I told you a long story about relationship stuff, right? And so hopefully you know that by now. But here is an example of our multi-step equation. Why does it involve multi-step? Because notice that I have not just one thing to get rid of, I have 2 things. On the left-hand side specifically, I have the negative 2 and I have the positive 5. Which one should I get rid of first? Okay, see, okay, good, it's fine. For those who said negative 2. Remember we talked about this long distance versus next door neighbor kind of deal. We talked about that before. If you still don't remember that part, then I should introduce this to you now. Always remember of me when you solve an equation. I'm sad. Sad, man. Oh wait, does this remind you of anything?
Hem does. Yeah, Hem does.
Hem does. But what? Backwards. Look at that.
Whoa, it is.
It is. Right. But notice, at this time around, we're doing everything in reverse. Addition, subtraction, the first thing to go. Multiplication, division is the next thing. And of course, exponent and the power. Exponent in the parentheses will be the last thing to solve for. That's setting up for you if you want to be solving for an equation. Okay? So, adding, subtracting means you're getting rid of the whole term, right? Division and multiplication is the coefficients only. Okay, there you go. So we're working backwards like this. 5 is a whole term or coefficient? See? Therefore, we have to get rid of it first. There you go. So, minus 5 over. You have negative 2x equals 2, 3, right? And now you have the new equation right here to tell me, is negative 2 a coefficient? That's what we want to get rid of? Is negative 2 a coefficient? Yes, it is. There it is. Division or multiplications. And so you either multiply by reciprocal or divide by negative 2 both sides. And so you end up with that answer. That's the equation for you. Okay. And another way to remember is the farthest variable or number is the first thing to go. The closest, near next to you, is the last thing to go.
Wait, you said the closest, where are you right now?
I'm the x.
Oh.
Remember that? I'm the center of the universe. I'm the x. The most important thing, I'm the unknown in a sense. So always visualize yourself as the unknown variable. And so you want to solve for yourself, you got to get rid of things that are farther away first and then lay this next to you. Okay, cutting tie to the relationship. Okay, questions on that one? Okay, so as it gets a bit more complicated, I'll show you another one. See if you can actually clean this up for me. Not because I don't like you or anything like that. There. Look at that problem. Who thinks it's hard? Okay, let's complicate it. So here's my advice for you. Do it one side at a time. What does it mean, do it one side at a time? It means we have the left-hand side of the equal sign, we have the right-hand side of the equal sign. Clean up, meaning simplify it as much as you can on each side before you start moving your terms around. So look at the left-hand side, right there. Is there anything here that we can actually clean up on the left-hand side?
Yeah.
Yes, what is it?
Change the negatives to a positive.
Very good. Change both negatives into a positive, so I have -2 plus 2x now, plus 8. Still doesn't look as nice yet. Is there anything else we can do on the left-hand side? Can we combine like terms, anyone? Do you have like terms?
Yeah.
We do.
2 and 2.
Look at that. If I cover out the 2x, what do you see?
2.
-2 plus 8. Whoa, those are two numbers. I can combine them. What's -2 plus 8?
6.
6. So I have 6 plus 2x equals to -5. Does it make sense so far? I'm cleaning up as much as I can to help me solve for my variable. So now notice it's cleaning up. There's nothing left that I can do to simplify more. Then I can start moving my terms. Now if I want to solve for x, remember this is my center of the universe. Which one should I get rid of first?
6.
There you go, the 6. How do I get rid of this whole term? Minus the 6 over. You will have 2 times x equals 2. What's -5 minus 6? -11. Perfect. And then now you divide by 2 both sides, right? Or times it by the reciprocal if you want. But your final answer is? What? -11 over 2. Or -5. Point? 5. Just well. Any question on that? What do you think of that one? Okay. Yet another problem that's going to, shock you. Because you're in Algebra 1 and that's the nature of it. The shocking nature of Algebra 1. So pretend I have this deadly problem. Now, who can solve this?
Not me.
Not me. Yeah, exactly. That's what I hear all the time, right? But then, let me just simplify the process for you. Hopefully you remember this too. How many fractions can you find on each side?
2, 1.
On each side. On each side. On each side, it has 1. Okay, so you notice that this is -3/5 on the right-hand side. That's 1 fraction. Why is the left-hand side considered as 1 whole fraction? Yes?
Because there's no other fraction.
There's no other fractions, just 1 bar. I know even though -3x plus 8, that's considered to be 1 whole group, right? 1 whole thing over 4 is still technically 1 fraction, isn't it? So we have fraction on each side. Now here's the thing that you remember for the rest of your life. When you have fraction on each side, the best way to solve for this is to cross multiply. Remember that one? Look. Oh, you start. Look. And to make it all beautiful for you, I'll then top it off with a butterfly. Yes. There you go. Here's the button. There. Look at that. Perfect, isn't it? Fraction on each side, I remember my butterfly. And then I just cross multiply. That's all we're doing. And notice that when we cross multiply, I'll just go with the red right here, just to remind you. Oh, watch. 4 times -3 is -12. On the left-hand side, I have 5 times -3x plus 8, isn't it? Does it look better now? See it? Okay, so what do I get here on the left-hand side? What do we do? Distributed property. Very good. So I take that 5 and distribute. Notice I bring down the plus sign. 5 times -3x? -15x. 5 times. A lot of people will skip this last step for some reason, I don't know. But when you're distributing, you have to distribute to every single term. 5 times 8? 40. Please do not ever forget that part. And on the right-hand side, what do we have here? Still with -12, right? Look, turns back into a multi-step equation. How do I solve for x now? What's the first thing to get rid of?
Subtract 40.
Subtract the 40. So here we go. Subtract the 40. I will have negative 15x equals 2. What is negative 12 minus 40? Negative 52. Good. Same sign. You put them together. Opposite sign. You just subtract. You know? That's the easiest way to remember. And the last part here is to get rid of the negative 15. How do I get rid of negative 15?
Reciprocal.
Reciprocal. Let's just do reciprocal today. Right now. What's the reciprocal of negative 15? Don't forget the negative, still, because of the negative. Negative 1 over 15, negative 1 over 15. Okay, so why is it here that they got canceled out? Because of that, remember? They got gone. You have x left, and over here, you got negative 52. Let me put the answer up here for you. Negative 52 over negative 15, right? 2 negative would turn into a positive, so my answer is a positive 52 over 15. Of course, if you can simplify that, which we can, right? Can we?
Yes.
Can we simplify? No? Yes or no? Okay, then we just leave it like that. Okay, that's how you solve a long problem like this. Question now. So you see the technique already, right? One fraction on each side, we make a butterfly. Yes?
How come you did like the 5 and the negative 3x the same, but not the 4 and the negative 3?
What do you mean? Which one?
Because you know how to learn like cross?
Yes, cross. So what about it?
No, just like, I don't know.
Okay, tell me. No, tell me. What's going on? What confused you?
Because like the 4 and the negative 3.
Okay, 4 times negative 3 is negative 12. The negative applies to one number. It's not both, right? If you apply to the negative 3, then stick with that. Otherwise, if it applies to negative 5, then the 3 is a positive. See? You have to decide which number is the negative you're going to stick with. Not both, just one. Okay, any other questions so far? We're good with this, right? So that's going to wrap up your solving equation with multi-step, right? Now another one I bring up today is teach you how to count numbers. You know? Yeah, I want to say teach you to do Gangnam Style. No, no. Counting numbers. How many of you know how to count numbers in this class? What about the rest of you? You don't know how to count numbers?
No.
Okay. Here's the first set of numbers I want you to count.
Wait, is this another lesson?
It's the same. It's yours. Do you know what consecutive numbers are? Give me consecutive numbers, please. Okay, so notice what you said. You did not skip anything. You just start counting. 0, 1, 2, 3, 4, 5, and it goes on and on forever to infinity, right? To infinity and beyond. Now, next set of numbers. Let me just gonna go and break it apart now and tell you, what about consecutive even? Can you give me a set of consecutive even numbers?
0.
Okay, 0, good, you start with 0, 2, 4, 6, 8, and that goes on forever as well. What about consecutive, what do you think I'm expecting next? Good, odds.
0, 1.
Okay, and do we have 0 for odds?
No.
No, we start with what? 1. We have 1, 3.
5, 6, 7.
Okay, now, I'm gonna rely on your expertise on number because you are so well trained, people. And so let me ask you this question. Look at this consecutive number set. What do you notice as a pattern here to get from one number to the next?
Adding 1.
Thank you very much. You are adding 1 in order to move forward by a number. Is that true?
Yes.
Now, I should draw carefully. There. Now, look at my consecutive even. How do I move from one number to another? Plus 2 to move forward. Notice, I add 2 to move forward. 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, so on and so on. Look at my consecutive odds. How do I move one number to the next? I also add 2. And this is the one that I want to mention, that a lot of people mess this up. This last 2 right here. They think that if it's consecutive evens, it's logical to add 2. But if it's consecutive odds, you have to do like 1, add 1, add 3, add 5, and so on. That's not the case because every single digit is different by 2. So whether you're doing a consecutive even or odds, the basic framework of it is still skipping by 2. Okay, so keep that clear in your head as we work on this next set of problems. Watch what happens. I want you to give me 4 consecutive numbers right now. Okay, fine. You have to make it easy, right? No, I don't want to make it easy. How about 3, 4, 5, 6? 3, 4, 5, 6. Okay? So I have 4 consecutive numbers. Do we agree that these are called consecutive numbers?
Yes.
Good. Can you add them up?
Yes.
Go ahead and add them up. What's your answer?
18.
How did you get to the answer so quickly?
Because
What did you do in your head?
6 plus 4.
Thank you very much. 6 plus 4, you move the 4 closer to 6. When you're moving the 4 closer to 6, what property is that? Commutative property. And then when you group them together, what property is that? Thank you. We're reviewing as well. It is 18. Okay. Any questions so far? That's easy, right? Now here's my thing though. Do you agree that we can call this our first consecutive number? This is our second consecutive number? This is our third consecutive number? This is our fourth consecutive number? We agree, right? Okay, who doesn't agree with me on this part? Okay, now watch what happens. What if, instead of giving you, guys, 3 plus 4 plus 5 plus 6 is 18? That's easy. What if I say, guys, I take my first number, plus my second number, plus my third number, plus my fourth number, the outcome is 18. Can you find me the 4 numbers? Pretend now that we don't know the 4 numbers yet. We have to find them ourselves. What if we have to do that ourselves? How am I going to get this done if the only clue that I have is we have 4 consecutive number, and that when you add these 4 numbers together, the sum is 18. That is the only clue that you have. So how do we get this job done? Well, it's actually really simple. It goes back to what do we know and what we don't know. What do we know already?
18.
We know the sum of all 4 is 18. We also know that these are 4 consecutive numbers, right?
And adding.
And that what we don't know is, what are my 4 numbers, right? What we don't know, we use what to define what we don't know. What is that called? Variable. Variable. So watch this. Can we just go ahead and do this? For my first number, since I don't know what it is, what letter do you want to use to represent the first number? N. Okay, here we go. Here is my first number. Now, before you start, naming, oh yeah, let's use M and Q and R for my next 3. Think about this for a minute. Can I write my second number in terms of my first? What did you know about consecutive numbers? That the second number, how is it related to the first?
By 1 or 2.
By 1, because it's consecutive, right? So it differs by 1. So how do you write the second consecutive number using my first? N what?
And 1.
Thank you very much. N plus 1. Look at that. Is that true? If my first is N, my second is 1 more than N.
Oh.
See that? See how that works? What if my third is now?
That's 2.
Thank you very much. And my fourth? And look, we have ourselves an equation.
That's so awesome.
Okay? Okay, so how do we solve this? Watch what happens. 1n, 2n, 3n, 4n, right? So 4n. We have ourselves 1 plus 2 plus 3. What is that? 6. Equals to 18. So we solve for this. Minus the 6 over. That will give us what? 12. So we have 4n equals to 12 divided by 4. And n is?
3.
Oh, look at that. If n is 3, then my next number is 4, 5, 6. Did we just find our 4? There it is. And that's how we do it.
Wait, does it work all the time?
Yes, it works all the time. Okay, are we clear on that part so far?
Yes.
Okay, we're good. Now, that is for consecutive numbers. What's happening if I have consecutive odds or consecutive evens? So we're going to do a case on that right now too to explain to you how it works. So watch what happens as we do it. And by the way, if you want to see this again, it's online, okay? So don't worry about it. So here's my, give me 3 consecutive even numbers. Oh, no, let's do odd. Consecutive odds. Go ahead. 5, 7, 9. Okay. So 5 plus 7 plus 9. Can you add them up and tell me what the sum is? 21, right? So watch what happened. Here's my first consecutive odd number. Here's my second consecutive odd. Here's my third consecutive odd. So we're doing consecutive odd numbers, right? Okay, now once again, pretend now that I did not give you any of the numbers. And instead, the only thing I give you is I want you to find 3 consecutive odd numbers whose sum is 21. So now let's go back and put in our definition of the first. What do we use to represent the unknown, the first number? Okay, so we use n. Now here's the tricky part. How? We can use whatever you want. X, Z, whatever you want. How do we define, think carefully before you answer this, okay? What is my second number going to be in terms of the first? Oh, notice what he said. Not n plus 1, but n plus 2. Why n plus 2? Because each number is being skipped by 2. Even if it's odd, I don't really care. But notice from one odd to the next, it's skipping by 2. What do you think the next one's going to be?
4.
N plus 4. Are we clear on that? On how to define our numbers?
Yeah.
Okay, so watch what happened, okay? We start combining. 1n, 2n, 3n. We look at the numbers. 2 plus 4 is 6 equals to 21. We minus the 6 over. We have ourselves 3n, 3 times n equals to 15. Good. Divided by 3. And then so n is 5. If our first number is 5, what is our next? 7 and 9. Didn't we just get back what we started out with? There. Yes.
If you only get like the answer, how do you know if it's consecutive, odd, or consecutive?
I'll tell you exactly what they are. I will give you the sum of 5 consecutive even numbers is. I will tell you what kind of numbers they are. Okay? So that if I don't give you that clue, you will not know whether you're going to be skipping by 2 or skipping by 1, right? Is that clear? Okay. Do you have a question on that one? Are we clear? Okay. If you are clear, I want you to do this for me, okay? I want you to go ahead and find 3 consecutive odd numbers whose sum is 99.
Whoa.
Okay. So, here's the clue. 3 consecutive odd numbers whose sum is 99. I want you to come up with your 3. See what you have for me. Anyone care to comment on my first number? What letter you want to represent your first number? Yes.
31.
No. I don't know. Yes. What do you want to represent your variable? Huh?
Why?
Okay, y. If y is my first consecutive odd, how do I represent my second consecutive odd? Anyone want to comment on that? Yes, Ivana.
Y plus 2.
Thank you very much. So my second now is y plus 2. I should be consistent with my y. What about my third? Anyone? Yes. Thank you very much. Y plus 4. So I think that's enough already, right? Go ahead and help me solve this to see what your answer is going to be.
Y plus 5.
Huh?
It's 31.
Your first number is 31?
Yes.
Okay. So what's my next 2 numbers? I want 3, right? I want 3 consecutive odds. 31.
31, 35.
There you go. Easy, right? So really, this is all you're doing. Equals to 99, right? Do you need to explain this anywhere?
Yeah.
We understand what we're doing, right? Yes, I do. Yes. So 1y, 2y, 3y. 2 plus 4 is 6. Set up equal to 99, right? And I solve. Subtract 6 both sides. 3y equals to 93. Divided by 3. Y is 31. So if my first number is 31, plus 2 is 35, plus 4 is 37. Question on that? I'm sorry. 31, 33, 35. Okay, we're good, right? All right. So here's my next thing. I'm not going to write it down. I'm just going to ask you to do it. Tell me the answer to this. Find 3 consecutive even numbers whose sum is 66. Let's see who's going to give me the first one.
What number was the last one?
Wait, is it odd?
Even. Consecutive even whose sum is 66. 3 consecutive evens whose sum is 66. Let me see if you can have your 3.
20. Can I do it too?
You have your answers already. Go ahead and speak up out loud.
20.
Yes.
20.
So you got to give me all 3. I asked for 3 numbers, right?
20, 22, 24.
Perfect. Okay. So we are officially done, people.
20, 22, 24.